The generation that a quark or lepton belongs to will be determined by the flavor and prime properties of the scalar boson. For example, we have a C quark and an S quark, and the flavor property that will be carried by the boson plus and the boson zero in the composition of these will be differentiated. Now, if we look at this C quark, we'll see that this boson plus 1 is combining with a minus 1/3 generic quark. So the minus 1/3 and the boson plus will give us a 2/3 electric charge on the C quark. And the generation it belongs to will be determined by the flavor quality of the boson plus, which we will examine in detail later. And if we look at the S quark, which is also composed with the minus 1/3 generic quark, but a boson zero, giving it an electric charge of minus 1/3. And we will see the scalar boson will also give it its necessary flavor charge or flavor property. Now we can go up here and see that we have a C quark and an S quark again. And we'll see now that the C quark is now being composed with a boson zero, as before it was being composed with a boson plus. But the boson zero now is combining with a generic quark with a plus 2/3 electric charge. And this will give us all the necessary properties of the C quark. And in this case, we will find that the composition will include a flavor contributing generic flavor rishon that is necessary to give it the required properties in the standard model. And for the S quark now, we have minus 1 scalar boson composing with the plus 2/3 generic quark, and therefore leaving a minus 1/3 electric charge for the S quark. And we will see later how by choosing the appropriate flavor rishon to compose this scalar boson, the S quark will have the required quanta of the standard model. Now we can go to the leptons and look at the muon and the muon neutrino. And we can see that we have a generic minus 1 lepton combining with the scalar boson 0 to give us one configuration of the muon. Again, in this case, not flavor, but we will see that there will be a prime property contribution from the boson 0 that will establish the generation of the muon. And if we look over here at the muon neutrino, in this case it's being composed with the same minus 1 lepton, but it's being composed with a boson plus, which then negates the electric charge of the generic lepton and it has an electric charge of 0. And then again, as stated previously, the prime properties that establish it in the second generation, we'll see later, will be contributed by the boson, the scalar boson. Now, let's look at the other examples of these. So here we have now the muon, but this time the muon is being composed with a scalar -1 boson and a 0 electric charge lepton. So leaving a -1 charge on the lepton and the prime contribution of the scalar boson manus to determine its generation. And then we have the muon neutrino, which now is being composed with a boson 0 and a generic 0 lepton, leaving again a 0 electric charge here on the muon neutrino with its prime property for its second generation inclusion being provided by the scalar boson. So in that way, we have all of the quarks and leptons of the standard model composed with combinations of the generic quarks and the scalar bosons carrying the prime and flavor properties.